So they can give you something like this. Let's say they give you something like this, and they say solve for x for which the series, or rather the sequence, will converge. This, I'm not calling it a series because there's no addition signs between numbers. There's commas between numbers, right? A sequence, there's commas between the numbers, but a series, just like what you see in sigma notation, there is now additions between numbers, right? So remember, this is a sequence, while this is a series, right? So one and the same thing, but it's just that the difference is with the additions and the commas, right? So from here, if they ask you to solve for x for which the series, or rather the sequence, will converge, for it to converge, remember the common ratio must be between -1 and 1, right? So the common ratio must be bigger than -1, and at the same time it must be smaller than 1. So we're going to have to find the common ratio, and then we'll substitute it there, and then we'll solve for x. So let's find the common ratio. So we can find the common ratio by either saying term 2 divided by term 1, or by saying term 3 divided by term 2, right? We can do anything there. So I'm choosing to say term 3 divided by term 2. I'm choosing the more complicated one so that you understand. So term 3, which is this stuff, divided by term 2, which is that stuff. So whenever you're dividing fractions, remember, you change the division sign into multiplication, and then from here you keep the first one like that. You keep the first thing that appears like that, right, without changing anything. While list, the second one, you switched it, right? So it's called tip and time. So whatever is down goes on top, whatever is on top goes down, right? This is the rule of division of fractions. We just change division sign into multiplication, and then we switch them, right? What's down goes on top, what's on top goes down, right? So then from here, we now cross multiply. I've got videos where I do cross multiplication. So when you cross multiply, we have to find, for instance, let's cross multiply this one. So here we're not literally multiplying. When we say cross multiply in this case, we're actually kind of dividing. So we're finding what's the highest common factor. So highest common factor is a number that both of them can divide by. So what is the highest number that both of them can divide by, right? So common factor, it means it's a number that both can divide by. But what's the highest one? Well, the highest number that 4 and 2 can divide by is 2. Just before I continue, if you want to be tutored, either online or physically, online, it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements. That 4 and 2 can divide by is 2, right? 4 can divide by 2, 2 can divide by 2 is the highest that both can divide by. So 2 divided by 2 is 1, 4 divided by 2 is 2, right? Now let's find the highest common factor for these ones. So how do we do it? For instance, let's just say here was a3, and let's say here was a2. Let's just say here's x. Let's just avoid some confusions. Let's just say it was something like this. Let's say we're cross multiplying this stuff. So when we're cross multiplying, when it comes to letters, we pick the one with the lowest exponent whenever the letters are the same, right? We pick the one with the lowest exponent. So the lowest exponent here is a squared, right? So we'll say a squared divided by a squared, which is actually 1. Then a cubed divided by a squared is actually a, right? A cubed divided by a squared. Laws of exponents, 3 minus 2 is 1, so it just remains a 1. So that's how we do it. Alright, so notice this is exponent 2, this exponent 3, so it's just like a letter appearing. It's just like a cubed and a squared. So we pick the one with the lowest exponent, which is this bracket squared. So what do we do with this situation? So this bracket squared divided by this bracket squared is 1, while it's this bracket cubed divided by this bracket squared, right? So notice, let me just make it more clear. When this bracket is cubed, this is actually what it means, right? This means this. So if I dividing by this bracket squared, which is actually this stuff, so this bracket squared means it appears twice in multiplication. This bracket cube means it appears 3 times. So notice this cancels this cancels this. So you see, 2 will cancel 2 of them, and 1 will be left, right? So that's what's happening. So if you see this bracket squared and this bracket cubed, this bracket squared divided by this bracket squared, everything cancels out, it's just left 1. While it's this bracket squared divided by this bracket cubed, this bracket cubed divided by this bracket squared, 2 of them will cancel and it will leave 1, right? So that's what we're left with. So I just illustrated what's going on by expanding it, right? But you don't have to do this part. It's just for understanding. I'm just showing you that this part is the same as this, while this part is the same as this. So if we divide them, it's like cancelling out, and only one of them will be left. So from here, notice this cancelled and it left one of them, right? So it's left x plus 1. So x plus 1 times 1, we now multiply along the same line. X plus 1 times 1 is still x plus 1. While list 2 times 1 is 2. Remember the 4 cancel and it left 2. So 2 times 1 is 2, right? So that's our common ratio. So our common ratio is x plus 1 divided by 2. So that's our common ratio. So we're going to substitute it. Remember, our first goal was to find the common ratio by dividing so that we can substitute it there. So we'll say minus 1 is less than x plus 1 divided by 2, which is less. So this is bigger than negative 1. At the same time, it's less than 1, right? So from here, how do we solve for x? Well, whatever we do in the middle, we have to do to the left and to the right, because it's like 2 of these inequality signs. It's the same as having 2 equal signs, right? So what you're going to do is you're going to get rid of the fraction whenever you're solving for x, you're going to have to multiply by the lowest common denominator, everything by it, right? So that x plus 1 over 2, when we multiply by 2, you see this will cancel out, right? When we cross multiply, they just cancel out. So the purpose of multiplying by 2 is so that they can cancel out and leave this. So we'll be left with x plus 1, right? I just multiplied by 2 so that they cancel out and leave this. So that's what's going on. Then 1 times 2 is 2. Then here minus 1 times 2 is negative 2. Then from here we need x to be alone, so we have to take it to the other side. So we'll take it to this side, and it's going to be 2 minus 1. And we'll also take it at the same time to the other side, right? Whatever we do to the middle, we do it to the left and to the right. So minus 2, right? Oh, I just made a slight mistake there. It's actually minus 2 minus 1. Here it's also minus 1, right? Because it was a 1, right? I was picturing as though there was a 2 there. So it's actually a 1, not a 2, right? So we take this to the other side, it becomes 2 minus 1, while we take this to the other side, it becomes minus 2 minus 1, right? Alright, so we have x is equals to 2 minus 1, which is 1, and here minus 2 minus 1, which is minus 3, right? That's what we have there. So it means x must be any value between negative 3 and 1. It will cause this sequence to converge, right? That's what's happening there. So there we have it. That's what it means, right? So if they say find the values of x for which the sequence will converge, you'll just have to find the common ratio, right? By either dividing this by this, or by saying t3 divided by t2, right? And when we divide them, we use the skills of cross multiplying. And then when we get our common ratio, we just substitute in place of r. Then we solve for x, right? So we figured out that our x has to be anything between this value. So let's say in the next question they chose one value, right? Remember, we can choose anything between this value. We can choose x as maybe 0, or x as maybe minus 2, or x as minus 1, right? But it's not only whole numbers. We can choose anything in this range. Then it will cause this to converge. Then they will say find the sum to infinity if x is equals to 0. So here they chose 0, right? So find the sum to infinity if x is equal to 0. So we got our x is equals to 0. So we cannot find the sum to infinity with this Greek language. We have to interpret it to English. So what do we do? Wherever we see x, we have to substitute it with 0, because they said x is 0. If they said it was 1, we're going to have to substitute it with 1. So let me substitute it with 0. So 0, if I put 0 here, 0 plus 1 is just 1. And then if I put 0 here, this answer is going to be 1 over 2. And then if I put 0 here, this answer is going to be 1 over 4, right? So I created my first 3 terms by substituting x. Then right after that, this is what you're going to do. So, okay, I hope this part didn't confuse you. I just substituted 0, right? I substituted 0, I substituted 0. This part wasn't showing. Alright, so you substitute whatever they say it was. If x was equals to 1, you substitute 1, substitute 1, substitute 1, so that you can translate it from Greek to English. Then from here, we need to find our sum to infinity. So our a is our first term, right? The value of the first term, which is 1, right? And then our r, if we say half divided by 1, is just half. Even if I say 1 over 4 divided by half, I'll get half. So our r is half. So sum to infinity is a over 1 minus r. So sum to infinity is a, which was 1 over 1 minus r, which was a half, right? So the sum to infinity will be equals to 2. And there we have it.